Okay, this is a non-calculator free response problem, so let's see what we can do with it. This is an interesting one because we're given values for the function up in the original line here. F of negative 3 is 4 and f of 3 is 1. We're told that the function is continuous on the closed interval, and f prime and f double prime have properties given in the table. So part A says, what are the x-coordinates of the absolute max and absolute min points? So let's first look for the local maxima and minima. Local max and min is going to happen at a critical point of the function, and there are two critical points, one where the derivative does not exist and one where the derivative equals 0. And you can see that the first derivative goes from positive to negative where x equals 1. So we are going to have a local max at x equals negative 1. And then at this critical point, the derivative goes from negative to negative, so there is no local max or min. So the absolute max is going to occur either at negative 1 or at an endpoint. The endpoint values are given. We know that f of negative 3 is 4 and f of 3 is 1. We do not know quite yet if the value of the function at negative 1 will be higher, but let's see. The function must be increasing starting at negative 3, going up to our local max right here, and then decreases throughout. So the absolute max must occur at x equals negative 1. For the minimum, we know that there is no local minimum, so it has to be at one of the endpoints. And because we are given the values of the endpoints, we can conclude that the absolute min is at x equals 3, because that is the lowest y value on the graph. That will have the lowest y value on the graph. They've only asked us for the x coordinates here, so we don't have to worry about the y coordinates. So that is part A. Part B, what are all the points of inflection? Specifically, what are the x coordinates of the points of inflection? Well, the points of inflection will occur where the second derivative changes signs at a critical point of the second derivative. So we go from positive to positive here, so that will not be a critical point, but we go from positive to negative here, so there is going to be a point of inflection at x equals 1 because f double prime changes sign. Okay, and part C says, sketch a graph given all the properties that we have. So let's try to do that. I'm going to erase everything I have here. First thing I'm going to sketch, and I need to draw a little grid, which I'm going to put way up here. First thing I need to sketch is that f of 3 equals 1 and f of negative 3 equals 4 up here. Now I know my function must be increasing and concave up to negative 1. So increasing and concave up. And remember, this function is continuous. Then at negative 1, my function has an undefined derivative and second derivative, and then switches to decreasing but still concave up. So I've got a cusp here that I need to deal with. So I'm decreasing, still concave up. Then I must have a horizontal tangent line at x equals 1. And I must continue to decrease because of this negative, but now switch to concave down. So I have an inflection point at x equals 1, and I'm switching to concave down, and there is my graph.